Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Here we see a third order non-homogeneous differential equation with the variable coefficients. In this differential equation, the coefficient, this one is denoted by P naught. All the derivatives are P naught, that is the first order derivative of P naught is 1 plus cos x, derivative of this one is 1 plus cos x. Similarly, the derivative of this equation is P naught double dash, and this gives minus sin x. Similarly, the third derivative gives minus cos x. Moreover, this coefficient is denoted by P1, and it is equal to 3 plus 3 cos x. Differentiating, we get P1 dash is equal to minus 3 sin x. Again differentiating, we get P1 double dash is equal to minus 3 cos x. This coefficient is denoted by P2. This coefficient is denoted by P2. Now differentiating, we get P2 dash is equal to minus 3 cos x. Again differentiating, we get P2 double dash is equal to this one. Here we have a third order differential equation. To check whether it is exact differential equation or not, we have to take the expression P3. When the order is third order, then we have to start from P3. We have to take the alternate sign, and here we will have, after 3 we will put here 2 1 0. Here we will have first order, second order, third order derivative. Now putting the values from here and simplifying, we get 0. Whenever this expression is equal to 0, it means this equation is exact differential equation. Since this is 0, therefore equation 1 is exact differential equation whose first integral is. Whenever our differential equation is exact, then we have to write the first integral, which will be whose order will be 1 less than the original differential equation. Since here the order is 3, so the first integral will have the order 2, and here we will take P naught. Now this is the first integral. The order of this first integral is 1 less than this differential equation. Now this P naught, this is P naught, which is this one, this Q1, this Q2. These two are given by this formula. Q1 will be equal to P1 minus P naught dash. Now putting the values P1 and P naught dash, these are the values which are here. So putting and simplifying, this is the value. Similarly, this Q2 by formula will be equal to P2 minus P1 dash plus P naught double dash. All these values are here. So putting the values and simplifying, we get minus sin x. Now we have value of Q1, value of Q2, and value of P naught, which is this one. Putting all these values, and here this integration means here we have the function phi. So to write the first integral, we have to take this function, we have to integrate this function here. So putting the value, this is the substitution. In this equation, this coefficient is P naught. This coefficient is now denoted by P1. This coefficient is denoted by P2. For P1, this is the differentiation. For P2, this is the first order derivative. This is the second order derivative. Now this is the value of the first integral for this differential equation. Now we have to check whether it is exact or not. So on account of the second order differential equation, we have to take P2 minus P1 dash plus P naught double dash. Putting the values from here in this equation and simplifying, we get 0. This is the condition which holds. So for the second order differential equation, the condition of exactness holds. Hence this equation 2 is also exact differential equation. Equation 2 is exact differential equation whose first integral is. Since this is exact differential equation and it is a second order differential equation, so in the first integral we will take this coefficient which is p naught, and we have to take y dash and q1 y. So on account of this second order differential equation, we will take p naught and the first order derivative here. So this is the first integral for this differential equation. Moreover, this is the second integral for this differential equation. Now p naught, this p naught is again here. This coefficient was denoted by p naught. This coefficient is again here, and this coefficient is again will again be here, and this k1 by formula we have to determine in the next page, and we have to integrate this value. This is the integration of this function. This function value of this integral is this one. This is function pi, and integral of this function is here. Now we have to put the value in this equation. This is value of p naught, this is value of q1, and this is value of the integral. This p1 and p naught dash, these are the values which are here. So putting the value, now p1 is equal to this one, p naught dash is equal to this one. Simplifying, this is the value. Now this value is here, and this is p naught which is here. Now simplifying, that is dividing both sides by this bracket, we get this one. This is a linear differential equation in y. Now this, taking this p, to solve a linear differential equation, first of all we have to find the integrating factor. So putting this value for p. Now since the this is f dash, so in the numerator we have the root of denominator, so the integral will be log of denominator, and this simplification will be x plus sin x. Now the general solution will always be equal to here this y dash means dy by dx, from which we have to take y. So y into integrating factor is equal to integral q into integrating factor dx plus c3. So putting the value, now this equation, this expression will be cancelled with this one, so we get, now integral of sine is minus cos, integral of c1 is equal to this one, integral of c2 is this one, and this is the concept of integration. Now this y into this is equal to this one, and it is the general solution of the given differential equation.